All right, in this video, I'm going to be talking about combinations. So this goes along with permutations. So if you haven't seen permutations, I suggest you do that before looking at combinations. So combinations is an arrangement where order does not matter. So how this differs from permutations order does matter. Combinations is where the arrangement where the order does not matter. So that's the difference between the two. Permutations, order matters. Combinations, order does not matter. So we do have a formula for this. So we have n total objects, C for combinations, and we're going to choose R of them. N choose R. So the way this is going to work is we're going to have n factorial in the numerator. And the denominator, we're going to have n minus r factorial times r factorial. Now, if you're not sure, again, what factorial, the exclamation point means, that is a factorial, n factorial. So example like 3 factorial, that's like 3 times 2 times 1. Do know there is a special case where you have 0 factorial, which is just 1. So, first example, you are preparing for a trip. You have, should be in E there, you have a list of 7 books to read, but you can bring only 3 with you on the trip. How many combinations of books are possible? So when you're going through these problems, again, you need to ask yourself, does order matter or not? So you're picking 3 books. Does the order of those books matter or not? So if you said, oh, I have Dr. Seuss, this and that, is that any different saying I got this, that, and Dr. Seuss? No, you have the same. It's the same thing. The order doesn't matter. So this is a combination problem. So that's how you know that. So we need to figure out how many total am I choosing from. So we have a list of 7 books to read, but you can bring only 3 with you. So there's 7 total. That's going to be our n, because remember it's NCR. And then we have to figure out, well, how many am I choosing out of the 7? Well, I'm bringing 3. So we have 7 combination 3. So if I plug into the formula, well, that's going to be 7 factorial divided by 7 minus 3 parentheses factorial times 3 factorial. Now we could sit there and plug in and do all that. Our calculator, again, will handle a lot of this. So I just plug into the formula to show, hey, I know what's going on here. But then I'm going to let the calculator go the rest of the way. So again, if we want to do 7 choose, combination 3, we have to start with a 7 first. So I type in a 7 first. And then you want to go to your math button. Math button, go all the way over to probability and go to NCR, option number 3. So we have 7 NCR 3, hit enter, and we get 35 as our answer. So there are 35 different combinations of 3 books I can get from 7 books total. All right, one more example. So a restaurant is giving free pizzas to 2 customers selected at random from a group of 30. Oh, it's off the page. Restaurant is giving free pizzas to 2 customers selected at random from a group of 30. You and a friend enter the drawing. So we want to know, what is the probability that both of you win a free pizza? So we want to know, what's the probability that both of you get a free pizza? Well, let's think about that. So they're going to draw 2 names, and they get a free pizza. So does Joe and Tim differ from someone drawing Tim and Joe? No, because they both won. It doesn't matter who's drawn first or second. They're both winners. So the order does not matter. That's how we know this is a combination problem. All right. So we got to think about this. Since this does say keyword, they want a probability. Again, we're thinking about the part over the whole. So what's the specific scenario they're wanting? They're wanting to know, you and a friend enter the drawing, what's the probability that you both win? So they want to know both win, so you and your friend win, and the whole would be all combinations of winners. So let's think about that. If you and your friend win, how many different ways can you make a group of you and your friend? Well, it could be you and your friend and you, but again, order doesn't matter. So there's only one way that is going to happen. So we got to figure out, well, what's the total amount of outcomes? What's the total amount that this can happen? Well, how many total people are we choosing from? It says we're choosing from a group of 30, so we're going to have 30. And I know this is a combination, so I'm going to use C for combination, not permutation. And I'm going to choose 2 out of the 30. So 30, choose 2. So that's the same as 1 divided by, and you could go into the formula here if you want to. So 30 factorial divided by 30 minus 2 factorial times 2 factorial. But I'm just going to use my calculator to figure out that bottom piece. And when I do that, top is still 1. 30 combination 2, when you do that in a calculator, you're going to get 435. So what is the probability that both you and your win a free pizza? It happens 1 in 435 is the probability there. And that was combinations as it relates to probability.